Have you ever really thought about the magic that's happening inside your phone? I mean, we use these things for everything, but how do they actually know where they are, down to the meter? Today, we're going to pull back the curtain on one of the most incredible technologies ever invented, GPS.
Right? It's a fantastic question. This little box in your hand has never been to that street corner. It doesn't have eyes, yet it can guide you with pinpoint accuracy. The answer isn't just clever. It's a mind-bending story that actually starts thousands of kilometers straight up. Let's dive in.
So to figure out how it finds you, first, we've got to bust a couple of myths about what the Global Positioning System, or GPS, really is.
Now this right here, this flips the script on what most people think. Your phone doesn't send out any signal to find its location. It's totally passive. It's basically just an antenna, a listener, tuning into a conversation that's happening way, way above our heads.
And that conversation is coming from this, the Global Positioning System. It's this huge fleet of satellites. It was originally built by the US military during the Cold War, to keep track of their assets anywhere on the planet. But since the 90s, it's been open and totally free for anyone in the world to use. Each and every one of those satellites is constantly beaming out a super simple repeating radio signal. And that signal contains just two pieces of information: its own exact position and the exact time it sent the signal. That's it. It's a great analogy. Think of them like cosmic lighthouses, and your phone is just a ship navigating by their light.
Okay, so if the satellites are just broadcasting the time, how in the world does that become a location on a map? Well, the secret isn't about measuring distance at all. It's about measuring time with almost unimaginable precision. Here's the core secret. That signal from the satellite travels at the speed of light, and the speed of light is a constant. It never changes. So, your phone gets the signal, and it looks at the timestamp from the satellite and compares it to its own internal clock. That tiny, tiny delay, we're talking fractions of a second, is all your phone needs to calculate exactly how far away that satellite is. Time itself becomes a cosmic ruler.
So how does this actually build your location? Well, a signal from one satellite tells your phone it's somewhere on the surface of a giant sphere, with the satellite right at the center. Now add a second satellite signal. You get another sphere, and where those two spheres intersect, you get a perfect circle of possibilities. A third satellite narrows that circle down to just two possible points. And finally, that fourth satellite signal comes in. It not only confirms which of those 2 points is you, but it also does something crucial. It corrects for any tiny clock errors in your phone, locking in your exact location. Getting that location locked in requires a level of accuracy that is it's almost hard to believe. And to pull it off, the entire system depends on the work of one of the most famous scientists in history. And that is not an exaggeration. I mean it. Without constantly correcting for Albert Einstein's theories of both special and general relativity, GPS would be totally useless within minutes. This isn't just some abstract idea from a physics textbook. It's practical engineering happening in your pocket right now. So here's why. You've got two of Einstein's principles basically playing tug-of-war with time itself. First, there's special relativity. Because the satellites are moving so incredibly fast, about 14,000 kilometers an hour, their clocks actually tick a tiny bit slower than ours down here. But then there's general relativity. Because the satellites are so far away from Earth's gravity, their clocks actually tick a little bit faster. And it turns out the second effect is stronger. When you do all the math and you balance these two effects, the net result is that the atomic clocks on the GPS satellites run ahead of the clocks on Earth by about 38 microseconds every single day. That's 38 times millionths of a second. It sounds like absolutely nothing, right? Wrong. If the engineers didn't build a correction for that tiny 38 microsecond drift, the positioning errors would pile up at a rate of about 10 kilometers every single day. Your phone would think your house is in the next town over before you even finished your morning coffee. So yeah, every single time you use Google Maps or Waze, you're watching a real-world, practical application of Einstein's theory of relativity. The whole system is programmed to constantly adjust for it, just to keep you on the right path. And that path leads to so much more than just your next turn. This invisible utility, silently orbiting above us, powers our entire modern world in ways that most of us just never think about. So the GPS in your phone is usually accurate to within about 5 meters, which is amazing. But specialized systems, the ones used for things like precision farming or guiding self-driving cars and drones, can get that accuracy down to just a few centimeters. We're talking about the difference between a farm field and a single plant. And the American GPS system isn't the only game in town anymore. Russia has its own system, so do the European Union and China. And your smartphone? It's not just listening to one of them. It's listening to multiple constellations all at the same time. That's why you can get a location lock so much faster and more reliably today, even when you're surrounded by tall buildings. But here's maybe the most important takeaway of all. It's not just about location, it's about time. That hyper-accurate time signal from GPS is like the invisible heartbeat that synchronizes critical systems all over the globe. World banking transactions, air traffic control, global shipping, even our power grids, they all depend on this universal clock to function. So just stop and think about that. A Cold War military project, combined with atomic clocks, running calculations based on Einstein's century-old theories about the very nature of space and time, all of it working together seamlessly inside your pocket, just so you can find out where to get the best tacos in town. It is an absolute miracle of engineering.
And that's the reality, you know? We have built our entire global civilization on a foundation of these invisible signals from space, which leaves us with a pretty heavy question. What would a single day without GPS even look like? It's definitely something to think about.